Section 6.2 is multiplying and dividing radical expressions. I can multiply and divide radical expressions. That's our learning target and what we're shooting for. Big ideas. If a radical with an index of n and a radical with an index of n, okay, as long as a and b are both real numbers, we can multiply them together and rewrite it with one radical symbol. So as long as our indexes are the same, we can multiply our radicands and write it with a single radical symbol with the same index. A radical expression can be simplified when the exponent of one factor of the radicand is a multiple of the radical's index. And the product of powers that have the same exponent can be simplified. The product of radicals that have the same index can be simplified. In example 1 here, we're going to be multiplying radical expressions. We're going to figure out, can we simplify the product? And if we can, let's simplify it. So if we look here at A, my index is a 3. Here my index isn't listed, so we know it's a 2. And since 3 and 2 are not the same, this cannot be simplified. If I look at B though, I have a 3 for my index and a 3 for my index. Since I'm taking the cubed root of both, I can go ahead and simplify this. I'm going to rewrite it with one radical, make sure we have our index there. I'm going to take my radicands, negative 4 times 2, with my operation there. Taking the cubed root of negative 8, and we know from section 6.1 that we can reduce that. I need something that multiplies times itself 3 times to get to 8, which is 2, and to a negative, which is negative. So here, yes, we can simplify it. We can actually simplify it all the way down to negative 2. Now go ahead and give these a try. Here, we have a 4 and a 5. So since 4 and 5 are not the same, we cannot reduce that. In B, I have 5 and 5. Since those are the same, yes, I can reduce it. I'm going to have 5 as my index, and I'm going to multiply my radicands. Negative 5 times negative 2, and I'm going to get positive 10. And there's nothing else I can do to simplify that there. So we leave it just like that. When we simplify a radical expression here, we're going to simplify these very similarly to how we did them with square roots. Now it's just instead of groups of 2 or perfect squares that we're looking for groups of whatever our index is. So a couple different ways that we can do this. We can break it down and look for any perfect squares that go in there. 54 is 27 times 2. Okay, once we get to there, we know that the cubed root of 27 is 3. So I can take that 3 out. I still have this 2 left, so that stays inside my radical. I can do the same idea here with my x's. I can take and divide by 3. I get 1. And I get 2 as my remainder. So those remaining 2 stay inside. Okay? The other way here is we can keep going with this. If we're not sure what perfect squares are, or if we didn't divide and get perfect cubes are, didn't get one right away, we can break it all the way down to its prime factors using a factor tree. Now we can multiply these together. I have 3 times 3 times 3 times 2. X to the 5th. Now, I have my prime factors, and again, we just want the ends of the branches. So here I have a 2, a 3, a 3, a 3, and my x's. I want groups of 3. So I have a group of 3 3's, so 1, 3 that I can take out. I have a group of 3 x's, so I can take out my x's. Everything that's left goes inside my radical, so my 2 and my x squared. So either way, we get to the same spot here. And it really just depends on how comfortable you are with finding perfect cubes and breaking things down. Again, the variable up here, what I did is I took 5 divided by 3 and I got 1, remainder 2. The 1 came outside, my remainder went inside. Go ahead and pause here and give this one a try if you'd like. Okay, so 128 is 64 times 2. If you recognize that 64 is a perfect cube, you can go right over here. The cube root of 64 is 4. My 2 is left, so that goes inside. As far as my x's go, if I take 7 divided by 3, I get 2, remainder 1, and so the 1 has to go inside. If you're not comfortable with that and you're like, yeah, I don't really know about perfect cubes, I'm nervous I won't find them, what if I divide by the wrong thing first? That's fine, we can break them all the way down to prime factors. So break down your number any way that you can until all we get are prime numbers at the end of our branches. So here I have 2 times 2 times 2 times 2 times 2 times 2 times 2. 7 2's. And 7 x's. We're looking for groups of 3. I have one group of 3 2's. I have another group of 3 2's. And again, we're still just multiplying. I have a group of 3 x's. Another group of 3 x's. And what I have left and x there go inside my radical. Make sure we have our index. Here, we're just going to multiply these together. 2 times 2 is 4. X times x is x squared. Cube root of 2x. So we get to the same place. So if you're comfortable looking for perfect cubes and breaking it down from there, go for it. If not, break it all the way down to its prime factors, and then look for groups based off our index number. We have one group of 2's, so I write down a 2. We have another group of 2's, so I multiply by 2. Simplest form here. Same idea, we're just going to have to find our product first. So since our indexes are both the same, both 2's here, we can write this all as 1 square root. 72x cubed y squared times 10x y cubed. We can multiply our number parts together if we want to, or we can break them down into their prime factors first. I'm partial to breaking them down first because it's easier to do it when we have smaller pieces. So 72 is 9 times 8, which is 3 times 3, and 4 times 2, and 2 times 2. Okay, again, we're looking for perfect squares, so if you recognize that 9 and 4 are perfect squares, you can take those out as 3 and 2. Here, we have 5 times 2, and then we have an extra set of 2's here. If you're not sure about that though, guys, and then a 5 left. If you're not sure about that, write them all out. So I have 1, 2, 3, 4 2's, 2 3's, and a 5. And if you need to, cross them out as you go. 1, 2, 3, 4 2's, 2 3's, and a 5. As far as our variable goes, I have 3 x's, 4 x's. And if you're comfortable dividing by our index number and getting x squared, go for it. If you're not, write them out. My y's, 2 plus 3. Again, it's y squared times y cubed. Again, if you're comfortable dividing, putting your 2 here and your remainder here, go for it. If not, write them out. Now, because it's a square root, we're going to look for groups of 2. I have a group of 2's. I have another group of 2's. Another group of 3's this time. X's. X's. Y's. And Y's. So 2 times 2 is 4 times 3, 12. X squared. Y squared, and what's left, 5 and y, go inside my square root. Okay, same thing up here. We've gotten 3 times 2, 6 times 2 is 12. X squared, y squared, square root of 5y. And if we look here, guys, we know that our x and our y have to be positive numbers because otherwise we couldn't have taken these roots right here. Okay, if we look, the value right here and right here, those have to be positive because they're in square roots. That means that our x had to be positive because it's to the third power, and our y and our x here had to be positive because if we take them to the first power or to the third power, it would have had to have been a positive number in order to make it not a negative, and we can't take a negative inside there. So in order for it to be written as a square root, those had to have been positive values already, so we don't have to put the absolute values, but you can if you want to, because it's an even root. If you feel more comfortable writing those square roots, go for it. Okay, now go ahead and give this one a try. Again, we're going to break it down first. That's how I like to do it. Because they're both square roots, same index, I can rewrite them as one radical. So I'm going to break them down into their pieces first rather than multiplying them together because it's easier to do that when I have littler pieces. So inside my square root, I have a 3, a 3, a 5, and a 7. I have 5, 6 x's. X to the 5th times x gives me x to the 6th, and 7 y's. Y cubed times y to the 4th. Again, we add our exponents and get y to the 7th. Now, because I have a square root, I'm going to look for groups of 2. I have a group of 2 3's, that comes out. A group of 2 5's, that comes out. 1, 2, 3 groups of x's. 1, 2, 3 groups of y's. And whatever I have left, the 7 and the y, stay inside my radical. I can go ahead and multiply here. 15 x cubed y cubed square root of 7y. And that's going to be my final answer. Once again, guys, I don't need the absolute value bars here. We have a odd number here and an odd number here. So in this original square root, both of those had to have been positive values in order to make this work. So we know that in our answer, they're positive. If you want to put your absolute value bars there, you certainly can because we have an even and odd exponents. So even index, odd exponents, you definitely can if you want to, but don't feel like you have to. And I'm going to go ahead and stop this one here and continue on with another video.